Thanks for coming back from lunch and coming to this session. This is my second year at TechDays, and it's really great to be back. I love this venue. This is such a great room for doing a presentation. I want to say that I really value your time, and if at any time you find that this session is not what you were looking for, I will not be offended at all if you want to get up and go to another session. But with that in mind, I hope you'll stay because I really like doing this session. It's an opportunity to really go deep on coded UI tests. So for the first couple of years of evangelizing, which is what I do, evangelizing Visual Studio 2010, I spent a lot of time doing introductory talks. I was here last year doing some introductory talks on manual testing and test automation. And now that there's some pretty good awareness of what our test story is in 2010, I now get to go deep on some of the really fun topics. And so this is a deep dive look at coded UI tests. Now, for just show of hands, how many people have never worked with coded UI tests before? Okay, that's okay, not a problem. Even if this is a 300 level talk, but even if you've never touched coded UI tests before, we're going to start from ground zero and we're going to work our way up and then dive deep into exactly how they work. And really the title of this talk, Building Robust, Maintainable Coded UI Tests. So let's break that down quickly. Coded UI tests are a new test type in Visual Studio 2010 that allow you to do test automation of your UI, of your application. So that means that we're going to click on some things automatically, we're going to type some things automatically, and we're going to validate some things about your UI automatically, whether that's a WinForms app or a web app. And I'll talk about the types of applications we support in a moment. What does it mean to build a robust test? Well, a robust test should be one that can behave in an environment automatically, maybe as part of an automated build environment. And so being robust means that it can respond to changes. It's going to not generate false positives or false negatives, but it's actually going to be a good test for surfacing real bugs within your application. And of course, maintainable means that as your application changes over time, you should be able to evolve your test suite over time. Okay, so that's where we're headed. Once again, my name is Brian Keller. I'm a technical evangelist for Visual Studio Application Lifecycle Management, which really is a fancy way of saying anything that helps teams build great software. So I work in Redmond at Microsoft. If you're in the neighborhood, stop by. I'll buy you lunch. I tell everybody that, and no one's taking me up on it. So maybe someday I'll have 10,000 people come by and I'll have to buy them lunch, which is fine by me. I work on Visual Studio and have for the last 9 years or so. And I'm also on Channel 9. My blog has a lot of information on application lifecycle management, and specifically all of the demos that I do, all of the virtual machines that I use, I post those to my blog. So if you see something that you want to learn a little bit more about, but you don't want to take the time to set up your own environment with Team Foundation Server and Visual Studio, you can download the virtual machines that I provide. You can go through a set of hands-on lab documents on software testing, architecture. I just published a new one last week that shows the integration between Team Foundation Server and Project Server. So that's kind of what I do, and that's my way of giving back to the community so that you can kind of follow along at home. I have worked on 2 books as well. The one on the left is just for the broad range of application lifecycle management capabilities. So whether you're a tester, an architect, a project manager, there's probably something in there for you. And then the one on the right just came out. That's really targeted at the Team Foundation Server administrators or somebody who's doing some more advanced capabilities, such as setting up a source control repository or determining a branching and merging strategy or a backup strategy with Team Foundation Server. And so these are the session objectives. So here's what I hope we can all take away from today's session. In addition to understanding kind of the basics of a coded UI test, we want to help you increase the number of bugs that you find. And of course, we want to make sure that those are legitimate bugs. So having false positives is not a good thing. That results in what we refer to as the broken window paradox, where if you walk into a neighborhood and all the windows are broken, then what's one more going to do? And so people stop caring about the neighborhood. I'm sure you've heard that before. Well, the same thing with your tests. If all of your tests keep coming back and generating these failures, and over time people say, oh yeah, those tests are bad, we've got 100 failures in there, then you're pretty soon going to stop caring about your test suite. So we want to try to make sure that as much as possible, the bugs that we find or the failures that our tests discover are actually legitimate failures. And so there's some things you can do to try to optimize for that scenario. And then, of course, in doing this, you want to reduce effort. And so one of the things you might want to be doing is reducing the manual testing effort. That's a good reason to create automated tests most of the time. And then, of course, over time, as you start to maintain these automated tests and start to maintain the application and make changes to both, then we want to reduce the amount of effort that's required for both of those scenarios. So that's what I hope to show you. Now, what do you need to make this happen? What's your recipe for working with coded UI tests? Well, to start with, you'll need Visual Studio 2010 Premium or Ultimate. You'll also need or what I would suggest you get, rather, is Feature Pack 2. So if you go to your MSDN subscription, you can download Feature Pack 2. It does require you to have that MSDN subscription, but once you have that, then you can download Feature Pack 2, which really lights up some nice features specifically for coded UI tests, such as Firefox support and a really nice graphical editor that I'll be showing you, and Silverlight 4 support as well, which I'm not showing you today, but you could basically write automated tests against Silverlight 4 applications and then run those back as well. This does require that you are working with C# or Visual Basic skills. So I know there's other test automation solutions out there which allow you to use scripting or allow you to use kind of more gesture-based ways of defining your tests. This is not one of those solutions. So I'm not here to argue the merits of one approach versus the other. In my personal opinion, with C# and Visual Basic and the power of the .NET Framework, you can do a lot of really interesting things that you can't always do easily with some of the scripting solutions that are out there. But I just want to set that expectation that this is something that really your programmers on your team should be writing, and it's less something that a pure manual tester is going to be able to step into unless they're willing to learn some programming skills. You may want to also consider working with Microsoft Test Manager. So if you haven't yet seen Microsoft Test Manager, it's our manual testing solution in Visual Studio 2010. So your manual testers can use this to manage their test cases. They can run those test cases. While they're running those test cases, we can gather all sorts of interesting data about the test run so that if they find a bug and file it back to the developers, it's not only just this description of what happened, but it might be a video recording and an IntelliTrace file and lots of really rich information to help eliminate the, well, hey, it worked on my machine scenario, right? And so that's one of the things that we're doing in application lifecycle management to help testers and developers work better together. But one of the other things that I'll show you later on is how you can take a manual test case and you can actually graduate that to an automated test case and take advantage of some of the recording work that the manual testers have already done. So again, I'll show you a demo. If you haven't seen Microsoft Test Manager, that's okay. We'll take you from ground zero there. And then finally, of course, you need to have a testable application. So that means that you need to have an application which is compatible with our test automation framework. And so what does that list of applications look like? I know this is kind of hard to read even in this big screen, but I'll kind of break it down from top to bottom. So the things near the top are the things that are best supported. So web apps are very well supported, whether or not you're using ASP.NET or PHP or JSP on the background. We don't really care. We operate at the browser's DOM level. So you can really be using whatever you want on the back end. And we do support AJAX as well. We support Windows Forms, WPF, SharePoint applications. These are all really well supported. There's some links off of here that provide more information about these specific application types. So for example, you see SharePoint's up there. I would suggest downloading my slide deck and then following that link, and it'll provide some of the things that you should be aware of if you're testing SharePoint applications. It is supported, but there's just some things you need to be aware of as you build your coded UI tests. Firefox, we added support for in Feature Pack 2. Silverlight 4 in-browser applications are also supported in Feature Pack 2. Some of the things that are partially supported include Dynamics and Win32 applications. At the end of the day, we're using the accessibility harness within Windows to rely on our ability to automate a lot of these tests. So whether or not your application is going to be testable if it's built on Win32, the answer is it depends. It depends on the type of accessibility support within the types of functions that you're calling. So my answer to everybody is really just try it. After today, you'll see how easy it is to get started with a coded UI test. And so you can do a quick record of your application and play that back and see how well it performs or not. And then MFC is mostly supported as well. IE6, Chrome, Opera, Safari, Flash, Java, these are some of the things that we don't support today. Our testing framework is extensible, so there's opportunities for partners to plug into there as well. And I've also talked to a lot of customers that have gone off and built their own extensibility mechanisms for custom controls that you may have within your organization. So that's all well documented on MSDN. Okay? So I want to get out of slides for now and drop into a demo. I will come back to some slides which actually illustrate the things that I'm going to show you in the demo. So don't worry about having to frantically scribble down notes or anything like that. I've tried to go back and do that for you so that after you watch this demo, we'll go back and revisit some of the things that I'm going to show you with respect to the best practices. So to start with, we're going to be using a really simple application. And I did tell you that this is a 300-level talk. You might expect a more advanced application. I like to keep the application very simple and instead make the tests themselves much more advanced because I think that makes it easier to get into some of the more advanced topics around the coded UI tests. So here I just have a very basic application. I hit go, and it lights up a label. Okay, so that actually gives us everything we need to do to highlight the points that I'm going to show you. So I'll drop into Visual Studio 2010, and I'll create a new project. And this is going to be a test project, the same type of project you would create if you were creating unit tests or web tests or load tests. So we'll just create a new project here, and it's going to come with my default unit test. I actually don't need that unit test, so we'll go ahead and delete that guy. And we'll add a new coded UI test. Now, when the coded UI test first loads, it's going to give you an option, two options for how you can create this test. The first option is what we'll start with, and that is just to launch a recorder and start manipulating your application as you go, and it will record your actions behind the scenes and convert that to code so that you can then play that back. The other way of doing this is, as I described earlier, to take an existing action recording from a manual test that your manual testers were working with within Microsoft Test Manager and convert that action recording into C# or Visual Basic. So I'll show you that one later. Before I actually start this, let me just show you what we start with as a blank slate here. If you're familiar with the unit test that we give you within Visual Studio, then this is going to look very similar. So we decorate this with coded UI test as opposed to unit test. We basically have a blank test method down in here where we're going to add our code. And then you have things like initialization logic and cleanup logic, which gets buried down here that you can write some database cleanup code or some database setup code for all of your test runs. So it's just exactly what you would expect if you're moving from unit tests into coded UI tests. So we want to go ahead and generate some code here, and I will go back to that recorder by going to Test, Generate Code, and use the coded UI test builder. And then down in the lower right-hand corner, you'll see this coded UI test builder that has a few buttons on it. The first one, of course, is a record button. That's pretty obvious. Then you see this crosshairs thing. The crosshairs allows you to select controls that you want to validate. We'll do that momentarily. And then you can generate code with that last button on the right-hand side. So I'll just go ahead and start recording my actions, and now from this point forward, anything that I do on my computer, with the exception of manipulating the coded UI test builder itself, is going to be captured so that we can then convert that to code. So what I'll do is I'll actually launch my WPF test application. I'll type hello, Belgium, go. And then before I forget, let me close that, generate code. And I'll just give it a method name, and that's going to generate the C# code for me. And I'm done with the coded UI test builder for now. So now what you see is I have a single method, and we'll inspect this method in a moment. But let's, before we go any further, let's just run that to make sure that it does what I told it to do. So it should launch the WPF application, type that text in there, click go, and then close the application, which it does. So that's great. So that's working. Of course, we're not validating anything yet, so we're not sure that it actually displayed Hello Belgium correctly, but we'll go back and add that later. Let me first start by showing you what's happening behind the scenes when we call this method. If we go to definition on this, you'll see that the first thing we're doing is we are launching the application, and you'll notice that there's actually two ways that we can launch this application. One is we actually have the absolute path to the application, and the other is we have this alternate exe path. So what do these mean? Well, one of the things that we try to do within the coded UI test harness is we try to make your tests as robust as possible out of the box without you having to do anything else. And so if I jump down to this other class, which contains all of the definitions for the strings that I'm using, then it actually shows you what each one of these means. So we have a window exe path, which actually points straight to that application that I launched. And then we also have this alternate path because it looked in my environment variables and it realized that this was sitting within the Visual Studio directory as well. And so that's a really nice mechanism. You'll find this all over if you inspect the code that our coded UI test builder builds. And the other nice thing that happened here is that you noticed I actually launched this application by double-clicking on an icon, a shortcut icon on the desktop, and it abstracted all of that away. It didn't care that I double-clicked on it. It instead knows I'm launching this application. So it tries to get to the origin of your intent and use what you're trying to do to actually represent what it's going to play back. Okay? So let's go back to some more of where the work's being done. You'll notice that I had this tab in here. I'll show you some interesting stuff there in a moment. But before I do, I want to point out this XY coordinate that's taking place. So here we're clicking the UI button and we're passing in this XY coordinate. Now, this confuses a lot of people because they look at this and they think, oh, okay, well, the way that you're actually finding your controls is you're actually just going based on the XY coordinates of those controls. And so if I change my resolution or if I change the size of my application or if I change the position of my controls, all of my tests are going to break, right? Well, that's actually not what's happening. What this means is that it's going to find this control, this go button, and I'll talk more about how it finds that control in a moment. But we use another mechanism to find that control, and then when we actually perform the click action, we're clicking 15 pixels over and 13 pixels down. Now, why does that matter on a button? On a button, it doesn't really matter, but there are certain types of controls where this does matter. And I'll show you an example that you probably use every day. If you click on the start button down here, and you look at the shutdown box down here, you'll notice it's actually divided up into a few different areas. That's a single control. I believe it's called a split button. And in this case, it actually does matter where you click on that particular control. And so we always record that information, and when we're playing it back, we'll use that information to place the click right where you originally clicked when you recorded it. Now, of course, you may say, well, what if I change the size of my application or my button and that point doesn't exist? And we use some math behind the scenes to try to find the best approximation for where you would have clicked there. But the key point here is to understand that our framework is robust enough so that you can change the size of your application, you can move buttons around. None of that is going to break the test, okay? So that's really important to get across. So the next thing I wanted to show you is the new coded UI test graphical editor that we shipped with Feature Pack 2. And you'll notice I have this UI test file. This actually contains a lot of the metadata about the test that you're executing. So if I double click on this and I have Feature Pack 2 installed, this is the experience that I get. If you don't have Feature Pack 2, it'll drop you straight into the XML. So what you see over here on the left-hand side is a list of all of the actions that we were looking at when we dropped into that method. So here you can see I'm launching this particular file or this executable. I'm typing this text into the text box. I hit Tab, Go, Close. Now, one of the things I might want to do is clean this up. And when I typed Tab, I didn't actually have to hit Tab in order to go over to Go. And in some cases, you may not want to, because hitting Tab and going through your application and changing the focus from one control to the other, it may work fine today, but later on you may add some more functionality that says, as these controls change focus, do something else. And you may not want to do something else. You may just want to actually click that Go button. And so straight from within here, one of the things I can do is just delete that action, and that's automatically going to delete it in the code for me. I don't have to worry about it anymore. Another thing that I can do is start refactoring this a little bit. So let's go ahead and break this down into launching the application, playing with the UI of the application, and then closing the application. So I can split this guy into a new method, and split this guy into a new method. And it's just telling me that I have to go back and manually call the test harness. That's what I'm saying yes to. And we'll rename this to launch application. Rename this to test application. I'm really creative today. Close application. All right, we'll save that. And now what you need to do, of course, is come back to your caller. And it will become obvious in a few minutes why we're doing this. So now that's a little bit more modular, so I like that. We'll go ahead and save that. While we're at it, let's just make sure this still runs. It's always a good idea as you're going through before you get too far down to make sure that you haven't broken anything in your original test. And so that looks good. So let me show you a couple more things within this graphical UI test editor. So when I started breaking out these options, you'll notice that they are not in the order that I am calling them. This is actually just listed alphabetically. So don't get confused when you look at this list and think that we're going to close the application, then launch the application. It's really just in whatever order you specify back in that other file. So that sometimes throws people when they first start looking at this. The other thing you can do here is you can do things like insert a delay. So maybe you want to delay before the screen refreshes. Now, most of the time, you don't have to worry about inserting delays. The way our test framework actually plays back is it plays back at full speed based on when we see the UI worker thread finish. And so if you have a data grid, for example, and the data grid is fetching data from a database, we'll wait for that data grid to refresh before we try to run some validation logic against a column somewhere in that database. Sometimes, however, you may have some custom code or some custom asynchronous events that we can't detect when those are going to fire. And so in that case, you may need to go back and insert artificial delays so that you're waiting, 15 seconds or however long you know is going to be an adequate period of time before your UI is in a state that it's ready to be clicked to the next page or validated. I actually don't need that here, so we'll go ahead and delete that guy. The other thing you'll notice over on the right-hand side is a list of all of the controls that we're working with. So here you can see my top-level control. I have this WPF application window. I have the text box that we're working with. I promised you earlier I would show you how we actually found the controls. Since we're not using XY coordinates, the way we do this actually varies based on the type of application you're using. For rich client applications, we use what are called search properties. So this would be a Windows Forms application, a WPF application. Search properties basically allow us to compose an AND statement of a number of different name value pairs that will equate in exactly one match for us. So in this example, we only have one button that's called My Button. There's never going to be a case where this particular form or this top-level parent control has multiple controls that are buttons called my button. So we know that that's enough in order to find what we're looking for. Now, with web applications, it's a little more tricky than that. Because as you could imagine, you're not required to give every element within your HTML DOM a name. And so one of the things that we do there is we first start with the search properties. And after we've done the search across your entire application or scoped within the top level control we're looking for, you may have more than one match. Right? You may have more than one row within a table or more than one button that doesn't have a name. And so after that, we have a second set of properties that are called filter properties, and those get applied one by one in the order in which they're listed until we have exactly one match. And so if we start with 3 controls and we apply a filter and we get down to 2 and we apply another filter and we get down to 1, we think that's the control and that's what we're going to key off of. If, on the other hand, we start with 2 and we apply a filter and we're down to 0 controls, then that's going to cause the test to fail. Okay? So there's a lot of things you can learn from that. Number one is if you're working with HTML applications or web applications, you can benefit by improving your test scores by actually giving as many controls as you think you're going to be testing names. And if you start giving them names, then that actually improves our ability to find those controls. The other thing you can do as you start learning more about the types of applications you're testing and start analyzing the filter properties within here is you can start changing the order of those filter properties or adding and removing filter properties to make sure that you get a better hit. Okay? So those are search properties. The other thing I want to show you here is the continue on error. So continue on error is by default set to false. So what that means is if we can't find a control to click on or if we can't find a control that we're trying to validate, we're going to fail the test, and that's going to be the end of the test, and we're going to stop right there and throw the assertion that says that this test failed. Most of the time, that's what you want. However, there are a few circumstances where you may have things that only happen once in a while. So a good example of that is how you're typing in your browser and you occasionally get that box that says, do you want to autocomplete this moving forward? Well, you generally only get that once on a fresh computer, and then you say yes, always do this, or no, never do this, and then you don't see that again. Well, if you start deploying your coded UI test to other machines and you haven't taken the time to go through and prime the browser properties, then you may need to account for the fact that after you fill out this form the first time, you're going to get that dialogue, and you need to say yes to that. And that's a good example where you would say continue on error equals yes, because if we don't find it on subsequent events, that means that the test case can still safely continue. Okay, so I've got another note in my slide just to remind you where that shows up, and you can do this in code as well. But that's just another thing that I found as I start building my coded UI tests. It's a nice thing to know about. Okay. So at this point, we haven't actually validated anything against the application. So let's go ahead and do that right now. One of my tricks for this is to actually rerun the test without closing the application or without performing the actions that are subsequent to where we're validating. Of course, this is a very simple test, but let's say that you were validating a form field that appeared halfway through a multi-page wizard. In that case, one of the things you may want to do is just comment out everything else that happens after where you're validating, and then rerun the application just as a quick way to get back to the point where you want to add that validation. And now that we've got the application kind of frozen in this spot that we want, you can come back to test, generate code, and then we're going to use this crosshair we talked about earlier. I'll drag that up, and you can see how it's actually highlighting the regions of the application that we might want to validate against. I'll drop it on the label that I want to validate. One thing to point out is this little D-pad like you have in your Xbox controller. If you're having a hard time getting to a specific control you want to validate, either because it's really small or maybe it's not a visible control, like maybe a panel that just houses other controls, you can use this to go up, down, left, right within the control hierarchy. In this case, this is the control that I'm looking for. So I have this property bag of things that I might want to validate against. And I can select any number of these. I could validate against all of them if I wanted to. So is the text black? Is the text visible? Is the text equal to a certain value? In this case, I don't care about what it looks like at this point. I just want to make sure that that display text matches what I put into the text box. And so I'll say that this has to be equal. I'll give a method name for this. And I'll generate that code. So once again, let's run this one more time to make sure it's working. Looks right to me. Of course, we haven't tested the opposite case, so we don't know for sure that that's actually working because we haven't changed it to a different value. Let's go ahead and do that now. And so this is where you learn about how to override parameters that are saved within your coded UI test. The way you can do that is you can say this.UIMap. And if you look at validate label, you'll actually see that we have this other class called validate label expected values. And then on that expected value is the value that we are looking for currently. And we can override that with goodbye, Belgium. And so I would expect that this test is going to fail because the string no longer matches what we're looking for. So if we run this again, it should come back and fail. And sure enough, it failed. And if I drill into that test result, you can see that it was expecting goodbye Belgium, and it actually said hello Belgium. And so this makes sense to us because we just programmed it, but this isn't very helpful to a tester who may not be familiar with this particular test case. All they see is that these values don't match. They don't know anything else about what caused this to fail. So another thing that I like to do is I like to go into the assertion and manually override it with a method overload that gives me an additional string here if this fails. So what we can say is that label text does not equal text box text. Now that's really basic, of course. Probably in your test, you'll say something like, the sales tax plus the subtotal didn't add up to the total, or something that makes more sense for your application. But basically, if we run this again, and then it's going to fail. And we look at the build report or the test report, then you see we get a much friendlier message in here. And especially if you have a lot of assertions, I really suggest spending the extra 5 seconds to add something contextual for the tester here, because that's going to help them more quickly understand what actually is going on with this particular failed test case. Is it a false positive or is it a real bug that we have? So for those of you that maybe are in the front row, you'll notice that there's one problem we just introduced here. Because my test is failing, you'll notice down here at the bottom that we actually have multiple instances of my application running. Now, that's not a problem for our demo scenario here, but as you can imagine, as you start having tens or hundreds or thousands of tests running on a build machine overnight, then pretty soon you're going to be out of resources. Sometimes applications may not be capable of being multi-tenant. You can start introducing conflicts. And so we need to make sure that even if a test fails, that browser or that application closes automatically. Now, there's multiple ways to do this. One of the things you could do is you could come into the cleanup logic and you could cause that to automatically close any instances of the application after it's done. Another way you could do it is you could use try-catch finally blocks. That gets to be a little bit messy. One of the ways I like to do that is by using the using clause. And to do that, just come into your launch application code, and this will start to become clear why we actually broke up the launch and the close into their own methods, because now it makes it really easy to come in here and select the code that's launching the application. Paste that into my using clause. We no longer need to close it. We no longer need to launch it here. The one thing we do need to do is just go ahead and qualify this. And this. And we'll close the old instances here. And so if we've done this correctly, what will happen is it will actually launch the application, but if you're using, then once it goes out of scope, it will automatically get rid of that application. So that's helpful for us because we know that this test is failing. And so if we run this test, it should fail. And once it fails and exits that code block, it will automatically close out of that. And there, of course, our WPF application is gone. So this test is starting to get a little bit more interesting, but we're only testing one value right now. We're only testing hello Belgium against goodbye Belgium. So that's not very interesting. So one of the things we can do is we can data bind this test. And if you've data bound unit tests before, it's very similar to the way you would data bind a coded UI test. So I dropped into my test view window over here, and you'll see my list of tests over on the right-hand side. And then down here in the list of properties, we have this data connection string. And so if I click on the ellipsis for data connection string, I get a wizard that says, how do you want to data bind this test? You can point it to a database. You can point it to an XML file. I already have a CSV file that I'll use, so we'll point out to my desktop. And if we just take a look at this really quick, you'll notice that it's a very simple CSV file, an input column, an output column, and then all the values on the left and right are the same. So we'll use that. And then, of course, it shows my same information there. The next question is whether or not you want to add this as an item to your project. And I would recommend you do that. That way your CSV file is actually versioned alongside your project. So we'll add that as a deployment item. And now at this point, it marked up my coded UI test with this additional data source row. And so what this is saying is that we're going to point at this particular CSV file, and we're going to go through data access method of sequential. You could change that to random. You could change that to another data access method if you wanted to. And then that's the deployment item that we're going to be using. And so if I ran this now, it would basically go through my application once for each row within that deployment file. But I haven't actually bound that to the information within my test, which requires that. So let me do that now. This.UI map, test application parameters, and then my text box, set that equal to test context, which is a really useful class that contains lots of information that you can use as part of your test cases, both for coded UI tests and for unit tests as well. I'm going to bind that to the input column. That's just the name of the column within my CSV. And then we'll do the same thing down here. Okay. So now it's going one by one through the list of data in that CSV file. And that passed. And if I look at my test results down here, then you can see that passed 3 times, which is good. Now let me just show you one nuance here. If you change this coded UI test, like let's say we change this to we're expecting hello Belgium instead of hello world, and I save this, if I run this test again, it's going to pass. The reason for that is that I haven't actually redeployed this CSV file. So what you need to do is click on Build, Build Solution. This will then redeploy that CSV file. And now if I run this test, it should fail on that first instance. Sure enough, so you can see that it passed on the first and the second, but it failed on the, or I guess if it failed on the first one and it passed on the second and third. It's zero-based, so threw me off there. Now, this is okay, but we can do better than this, because one of the things that you may have noticed as we were going through our application is that the label text was correct. It was what we were looking for, but it had a formatting error. And so oftentimes you'll write UI tests that you can't account for every type of possible formatting error that could go wrong on your form. And so one of the things that I recommend for trying to make sure that your tests are actually behaving as they should is you can take advantage of the built-in imaging snapshots to actually take a snapshot during the course of your test execution. And then you can have your manual testers or somebody who's experienced with the application, maybe a product owner, go back and review those snapshots and see if they actually make sense within the context of the application. So let's do that now. Let me go ahead and fix first the coded UI params. Let's change that back to, well, let's keep it at Belgium. We'll go ahead and deploy that again. And so to take a snapshot is actually quite simple. What we'll do is we'll say image we need to find, there's a couple ways to do this. One is you can either take a snapshot of the entire desktop, or you can take a snapshot starting with any control within your hierarchy. In this example, I'm going to actually use the top level window that I have, and we'll take a snapshot of just that particular control. And you have this capture image on here. And after we've captured that image, we can save it. We'll be kind of sloppy with our file saving right now. I'm sure you can come up with a much better way to name that and to store it. But for now, we're just trying to show how this works. And so now if we run this again, it should pass again. But for each iteration, we're going to take a file and we'll save it as file.bmp, and then we'll attach that to the test result. So now if I open up my test run here, looks like everything passed. This guy looks good. This is the Hello Belgium. But then upon further inspection, you'll notice here that we actually had a formatting error there, so that's not good. And if we go into the other one, we had another formatting error as well. So this is a bug that my coded UI test didn't catch. And the reality is that we could spend a lot of time investing in coded UI tests to try to catch everything, when in fact, just a quick sanity check by a manual tester or someone familiar with the application could find a lot of these things very quickly. So in this case, we're saving it to the test context. I've seen other people take this and save it into a Word document, so you can actually get a really nice storyboard that someone can look at, or you can print it out and hand it to the product owner and say, hey, does this look right? There's lots of things you can do once you get those images and put them into really nice places. But once you have that information, it can surface some interesting bugs. And so one of the things I can do is I can actually just right-click down here, create a work item, create a bug that goes straight into Team Foundation Server. It's going to ask me to publish this test result. And by publishing that test result, it stores it in Team Foundation Server. And I can provide some more information here, but if you take a look at the attachments, we automatically include the test run information. And then maybe, this file was okay, so we'll go ahead and delete that. But we want to provide some more context back to the developer to say, hey, look, we need to change this this formatting. So that's just a really quick way that you can create coded UI tests. You can scale them up. You can make them more robust and more maintainable over time. I'm sure we could spend another day talking about lots of different techniques, but unfortunately, we don't have time to demo everything. So now I'm going to switch back to my slides and just take you back through some of the concepts I showed you and show you some other concepts you may want to explore on your own. So this is the using clause. So get used to using. It's useful. I like saying that. So again, this works for pretty much any application type. This is how you would do it for our WPF application. You could also use this for browser applications as well. The key thing is that once your application goes out of scope, either because it's finished running all of your test logic or because it's failed an assertion, then you can actually have that dispose of the object that you're testing. Understand searching and filtering. So this is really important, especially as you get into very complex applications, especially web applications, which again may not have all of your controls named. So I provided a link to an MSDN article that explains a little bit more detail about how this works. But again, at the top level, what we do is we start by generating a list of all possible controls using ands. So we're looking for buttons, and they should be named this, and they should be yada, yada, yada. And then if it's a web application, then we use filtering to then narrow that list based on some parameters so that we try to find exactly one match. And again, XY is only used for clicking within the button. It's not used for finding a particular control. Data binding, that's a really great way to get a lot of horsepower out of the coded UI tests or really any test type that you write. And so again, you can open up the test window, you can come into the data connection string and point that at your data source. I'm going to show you a different way of doing data binding using manual tests, and that actually does a lot of the work for you. So I'll come back to that in a moment. Make friendlier assertions. Again, this is only going to help you be able to sift through your tests faster and be able to pick out the false positives from the ones that you actually should care about. So again, spend the few minutes. It's as important as commenting your code, right? Comment your test assertions so that you understand what you're looking at later on. Here's the code for actually saving pictures, and you'll notice here that I have uitestcontrol.desktop.captureImage if you want to capture the entire screen and save that out. And again, my whole slide deck is going to be available after the show. Now, Microsoft Test Manager. I mentioned that as you're going through Microsoft Test Manager and you're working with manual tests, you may reach a point in time where a manual test is passing consistently on a regular basis, and it doesn't make sense for the manual testers to spend their time testing that anymore if it's easy for you to automate. And so one of the things you can do with test cases in TFS 2010 is you can actually use the built-in workflow to change the status to planned automation. And so that's something that a lead tester or a developer tester might do when they look across the list of test cases and identify candidates for automation. And so now let me just drop into Microsoft Test Manager and show you what this looks like. Out of curiosity, how many people have used Microsoft Test Manager before? Okay, fair number of you. So for the rest of you, I'll make sure that we start kind of from the beginning and quickly go through a basic example here. So Microsoft Test Manager can either be purchased standalone for your manual testers, or it's also included with Visual Studio Ultimate. And really, it's a tool that was built from the ground up specifically for software testing. You know, we didn't want to take a manual tester who has never used Visual Studio before and say, here, go install this 747 cockpit. Good luck. Let us know how you're doing. We really wanted to give them a tool that was dedicated to them. And so here you can see just a list of all my test suites, test cases over on the right-hand side. Again, I do a presentation where I take you through this entire thing. It's actually recorded and available on my blog if you want to see lots of detail on how this works. But let me just show you this test case, and this is the one that we're going to automate. You can see that we have the list of all the tests that the tester is going to run through. And when that manual tester is running through those test cases, one of the things that they have an option of doing is recording what's called an action recording. So if I run this test case, I can say overwrite existing action recording. I already have an action recording for this one, but I want to show you the process of creating an action recording. You may also want to recreate the action recordings if your application changes enough that it warrants going back and re-recording those steps. So I'll go ahead and start this test. And just like the coded UI test builder was automatically recording everything that I was doing behind the scenes, this does the same thing, but it can be employed by the manual tester, and it doesn't require you to generate any source code at this point. So to start with, it's telling me to launch this application. And this is a web application, so you'll see a slightly different experience for how coded UI tests are generated. And I'm just going to click through this application. And you'll notice that I'm actually taking the time to click pass or fail on each one of these steps. And that's not something that your manual testers have to do all of the time. If they had to do that, you know, I'm sure they would probably hate this product. The reason that I'm doing it this time is because I'm recording that action recording. And specifically, I know that I'm going to turn this into an automated test later on. And by actually separately going out and marking each test step as pass or fail, that allows us to associate the individual actions you're performing with that test step. And that makes it much easier to maintain and build that coded UI test over time. So now it's telling me to enter this value into this quantity field. It's already copied that into my clipboard for me. So I can just type that in there. Now it's telling me to click somewhere off of the form. And basically what we're doing is we're validating that if the user types invalid data in that quantity, like an A or a -5, we don't want it to go to -5 and all of a sudden we're paying people to shop from us. That would be a bug, right? So I validate this, goes back to the number 1, so that's good. And then let's just reset my application state and then close the browser. So now I've recorded it once. I'll go ahead and overwrite that existing recording. And the thing I didn't show you is that this test case is actually data bound within the manual test case. So we specified a parameter, which is the value we're going to type into that quantity field. And then we actually supplied the values within another form down below on that test case screen. So we can maintain that centrally over time. Maybe we find that -5 works fine, but -500 actually causes our app to break. And so we want to build a list of values over time that we test with. Now that I've recorded that action recording, from within the manual testing tool, I can actually just highlight. It's hard to see, I think, but I highlighted some steps there. And I can play that back. And it's just doing something very similar to the way the coded UI test played back my actions. And the idea here is that I'm not yet fully automating my test case because I still need the manual tester to occasionally look at the application and inspect it. And in this case, I'm making sure that this value is set back to 1, which it is. So I'll pass that, and I'll just, for fun, play the last 2 steps here. Oops, I selected all of them. Well, let's go ahead and pretend that passed, and we'll move on to the next test case. So I'm not going to finish this manual test case. I don't need to. I know that this is passing on a consistent basis, so we'll go ahead and save and close this. And now let's say that we want to turn this into an automated coded UI test. So I'm done with Microsoft Test Manager. And I've now flagged this test case for the development team who's going to turn this into a fully automated test case. As a manual tester, I've got new stuff to test, so we just want to make sure that we take this off of my plate and I can go test the new stuff, and we can wire up an automated test into our build process to see if we regressed functionality pretty quickly without involving a manual tester's time. So again, I'm going to create a new test project here. Get rid of our existing unit test. Here's our new coded UI test. And last time we wanted to build this from scratch. In this case, I'm actually going to point to an existing action recording. And now this is pointing back to Team Foundation server. There's my Tailspin Toys project. And I remember that that's test case number 41. I could also, of course, query for any test cases that are in that planned automation state. And now what it's doing is it's generating code based on that action recording. So here you can see that these aren't always the best looking methods, but these actually correspond to that manual test case. So if we go back to that manual test case, it's getting the names of those methods from the individual test steps within that test case. So if I go back to 41, oops, I want to go to the plan tab. You can see open the website there, the long URL, and then we encode it, and then click on model airplanes. And then down here at the bottom, I forgot to show you last time, this is the list of all the data parameters that we're passing in. So we're going to run this 3 times. And so the data parameterization is actually already done for us. So because we pointed this in an existing manual test case, it already knows that it should point to that test case. So there's the test case adapter. There's my TFS server. There's the test case number, and we're going through sequentially. So we get all of that for free. The other thing that we get for free is that it's automatically going to override the value that we need. So I didn't even have to type this text to override the value each time we go through that test case. And so now if we ran this, it would actually go through and it would run it 3 times, but we still haven't replaced the manual tester sitting in front of the system, making sure that this particular field is set to 1. So to do that, we can just add a validation step here. And so after I click on the white space, that's when the browser refreshes. And so again, I'm just going to generate new code for this. I'll launch my Tailspin application. I already have an item in my cart, so I'll just use that. Point to the quantity. And I want that quantity to have a text property of 1. Validate quantity. Reset my application state. And so there we have validate quantity. So now if I run this, it should launch and run my application 3 times for me. Sure enough, so that's good. We validated that customers are not going to hack through our website and leave with a negative balance in their cart. So that's good. The other thing I might want to do is may want to actually test this on Firefox as well. So in order to do that, I can easily come to the front of this test case and say browser window, .current browser equals Firefox. And if you do this, you'll actually see that the way that Firefox closes the browser is not really compatible with being able to quickly run these test cases. I'll show you exactly what that looks like here. So now you can see it's running within Firefox. And at some point, it's going to close this browser and go on to the next test case. But you're going to get an error if you try to do this. And the reason that that happens is that when Firefox actually calls the close, there's some internal logic, and I'm not a Firefox developer, so I couldn't tell you, but there's some internal logic that keeps the Firefox thread hanging just a split second longer than it needs to in order for us to start that next test case. And so then you get this error saying, hey, Firefox is already running, and it actually hangs your test case. So what I can do is I can stop that, and instead of closing it by using the click to actually close the browser, what I can say is this.ui map, and then find my top level browser in here. There it is. And that should do the trick. So now that's actually a smarter method. In this case, it's aware of the fact that we need to wait for a callback before we actually go to the next iteration of this test case. And there it is. Okay. So that's a really nice automation workflow if you're going from manual testing into automated UI tests. And of course, not everything is a good candidate for automation. This isn't a talk on how to choose which candidates are good for automation. I'm sure if you're in this talk, then you're already familiar with test automation, and you already have your own principles for coming up with what you think deserves a good regression test. And obviously, if you're going to completely rewrite the application and the UI in the next iteration, and it's going to totally break your automated tests, probably not a good time to be investing in writing automation. So you kind of want to make sure that the UI is going to be stable for a while, so that the payoff of your investment in automated tests actually shows some positive returns there for you. Again, some of these are just to rehash what we already covered. So continue on error, you want to use that if there's a dialogue or some other action that maybe only happens some of the time and you don't want the test case to fail if it does or doesn't happen. Testing with Firefox, so this is how you switch over the browser to Firefox. Make sure you have Feature Pack 2 installed in order to work with that. Multiple UI maps. So multiple UI maps are what I would consider to be maybe a 400 level topic. So I'm not going to show you creating a multiple UI map demonstration today. But multiple UI maps are basically what you would use if you had a composite application or an application that had lots of pages and you wanted to build maybe a suite of tests, and each one of those tests might actually correspond to one particular page within your application. Maybe you're testing a CRM application that has tons of UI, and you want to make sure that you can have multiple developers maintain and version control an individual page worth of functionality. You want to make sure that all of those pages can be orchestrated to be played together. Maybe you want to have the ability to run multiple new customer creations prior to actually going out and executing a payroll function. Those are all things that multiple UI maps are really good at. Our framework, to be honest, doesn't do a great job of facilitating that out of the box, but there's a way that you can work around to make this happen. And basically what you do is you start by adding multiple UI maps. You saw me working with a single this.ui map. But you can add multiple UI maps, and each one of those can contain the methods and the controls that make sense for that slice of the application. So maybe it's a composite app where you've got a complex control on one page, and you want to represent that complex control separately, or maybe you want to have one UI map per page within your wizard or within your application. However you want to factor it is up to you. If you want to do that, this blog post will actually take you through step by step how to do that, and you can download an example which shows how to do that. Again, I mentioned this briefly, but think about how you can make your applications more testable. So especially for web applications, you want to get in the habit of giving names to your controls so that those can be unique. You don't want to be renaming your controls a lot, so if you can upfront settle on a naming control, maybe it's Hungarian notation, maybe it's Pascal casing, whatever suits you, stick with it, and that can help you make your tests more maintainable in the long run. The other thing is to educate non-test developers on coded UI tests. So if there are people that are building applications, but they're not responsible for testing those applications, have a brown bag. Show them the way that you actually build test logic for your applications so that they know how to build those applications moving forward that are going to be more compatible with the way that you need to test them. If you never communicate, then of course it's hard for them to know what you're expecting there. And then of course, the reverse there is to educate manual testers on coded UI tests as well. And that doesn't mean that you have to give them a crash course on C# and Visual Basic unless they're interested in that. What I mean there is that if they're creating action recordings like I showed you, show them why it's important to actually mark each step as pass or fail, because later on when you're maintaining those tests and you're trying to refactor them, that can be really important to actually have those application interactions be isolated. A lot of people ask whether or not this works with load testing. So load testing is most commonly used within Visual Studio to throw lots and lots and lots of users at a website. You can also use it with unit tests as well. So maybe you want to test an XML web service and you want to say, at any given time, I might have 80% of my traffic out of 2,000 users calling this one particular function and the other 20% is calling another function. And so people ask, can I just load up a bunch of coded UI tests within a load test and say, simulate 1,000 users hitting this particular UI that then hits a backend database and shows how your application scales or not. And you can do this, but in order to do this, you would then have to have 1,000 physical or virtual machines in order to simulate 1,000 users. And the reason for that is that our coded UI test, for all intents and purposes, it thinks that it has control of the mouse and keyboard. And so there's a process for doing this, but again, the way that this works is you would have to go out and secure at least 1,000 virtual machines or 1,000 physical machines. You then install what are called test agents on each one of those boxes. And then those test agents are then responsible for orchestrating with the test controller, which sends them the tests and then collects the results of those tests. So it's possible, it can be done, but it's not as easy as saying this machine's going to generate 1,000 user load and you go home for the night. Playback settings is something that you would rarely get into, but I always like to show this just in case there's something that you need to be aware of. A good example is timeouts that you may need to change. So by default, I think I mentioned that our framework will actually play back as fast as possible, as fast as we think that the control is going to be ready. Sometimes that's not always good enough, and so you may need to tweak this, and there's some documentation which explains all the finer points, but I would venture to say that 90% of you in this room will never need to go into the advanced playback settings. If you're using an operating system other than Windows 7 or Windows Server 2008 R2, so if you're using Windows Vista XP, you should go get this platform update. You may already have it from Windows Update, but this basically updates the accessibility layers that Windows uses. And at the end of the day, that's going to make a much better testing experience because that's going to give us better access to all the different types of applications you might be testing with. And again, all these links are in my slide deck. This is just a quick look at the test architecture that you can put into place as you really scale out a testing solution based on Visual Studio 2010. Let me just quickly drop to this. This is also on my blog. So if you go to my blog and you search for one word SpeakFlow, then you'll come back with this. But it's basically a deep zoom application that you can zoom in and understand all the different components. So I just put this together because it's a nice way of kind of telling the story. At the heart of the solution, when you start to scale it up, you need to have Team Foundation Server involved because that becomes the store for your test cases, for all of your test results. You don't have to use Team Foundation Server in order to benefit from coded UI tests, but as you start taking advantage of things like lab management, which allow you to do complete build, deploy, test workflows, where you can say, every night I want to build my code, and then I want to push that out to one or more environments that may consist of SQL Server 2008, SQL Server 2008 R2, and SQL Server 2008 or 2005. And you want to have different flavors tested, 32-bit, 64-bit. You can then start automatically pushing that out to these virtual environments that will spin up. You can snapshot those automatically. If you find a bug, you can store a copy of that snapshot or a pointer to that snapshot for the developer so they can actually jump to the point in time where the bug was discovered. Really, really cool technology. As you start taking advantage of some of that, you will want to use Team Foundation Server. And of course, that's enabled by things like Team Build, which is our automated build solution, which then kicks off the deployment and then the test workflow as well. We have test controllers, which, as I mentioned, is used to actually orchestrate the tests across multiple machines. And then we have System Center Virtual Machine Manager, which is used for your lab management infrastructure if you're taking advantage of virtual machines. And then what a virtual environment may look like is something like this, where you have two machines, one web server, one database server. You install all the agents that you need on that particular machine. And then SCVMM is responsible for automatically restoring that to some known state. So maybe a clean, pristine state of the image before installing any of your software. And then you push your nightly build down to that software, take another snapshot if you want to, and then run all of your automated tests. And so I know that there's going to be a lab management talk tomorrow. So if you're interested in seeing lab management, I would definitely recommend coming back to that presentation. I'm sorry, I don't know what time it is, though. So hopefully this has shown you a little bit about what coded UI tests are, some of the capabilities and limitations with coded UI tests. Maybe you have some ideas for how you might use them. And as you go back and start using them within your organization, I would say, use this as kind of a reference to refer back to ways in which you may tweak those and get better performance and better testability out of your coded UI tests. There are some other resources as well. For example, one of the things people sometimes ask me is if our framework supports image comparison. So I want to be able to say, with pixel perfection, whether or not the logo appears on a certain location on every page, or whether or not this table is formatted correctly. And yes, you can do that. In fact, the product team has a lot of really great blogs out here. Sorry, that's blue on black. It's kind of hard to see. But if you get my deck, you can go out and look at some of the other blogs that are out there. My blog, of course, has a virtual machine you can download, like I mentioned. And then please take the time to fill out the evaluation form. That's how I get invited back or not, or you can tell me whether or not you want me to come back and how to refine my presentations moving forward. And I'll stick around for a few minutes after my presentation. Thank you very much.